Pole shift Earth crustal displacement, the climates and fauna of Siberia and Alaska, and the deaths of the mammoths, we finds it to be critically flawed. By the late 1960s the modern theories of continental drift and plate tectonics had become firmly established in geological thought. They had survived close scrutiny and challenges from competing hypotheses and propositions, both within and outside the scientific community. One of the most prominent unorthodox interpretations put forward was Charles Hapgood's Earth crustal displacement, which was never accepted as a truly valid competing scientific hypothesis, and Hapgood was not part of the geological community. Popularized in his 1958 book Earth's Shifting Crust, a key to some basic problems of Earth science, the Earth crustal displacement idea has re-emerged in alternative circles in the last decade. Its most vocal supporters are the librarians Rand and Rose Flamath and the journalist Graham Hancock. Hancock based a large portion of his book Fingerprints of the Gods, 1995, revised 2001, on Hapgood's evidence for catastrophe at the end of the last glacial maximum, 12,000 BP, before present. Earth crustal displacement is based on the premise that Earth's lithosphere, the outer part of the rocky Earth, about the uppermost 80 kilometers or 50 miles, has shifted as a whole at different times in the past over Earth's interior. Hancock, 1995, 11, went so far as to claim no geologist has succeeded in proving it incorrect. Results from pollen analyses have revealed patterns of climate change that are at odds with the inherent predictions of the Earth crustal displacement model. Studies have shown that the polar regions have either contracted or expanded toward the equator, but have never shifted their positions as required by Earth crustal displacement. The CliMap project, 1981, reconstructed climatic zones during the last glacial maximum and the results obtained shows the North and South Poles, and the equator, in the same position as today. Paleontological data, summarized by Thiede et al. 1990, reveals that the Arctic Ocean has continuously experienced polar climates, almost permanent ice cover and glacial-marine sedimentation for all of the late Cenozoic since the mid-Pleistocene. Phillips and Gans, 1997, reconfirmed that, regardless of how the climate has varied in the Arctic polar regions, they have been colder than the oceanic areas south of it for at least the past 7 million years. Earth's lithosphere is attached to the mantle in such a way as to make Earth crustal displacement impracticable. The mechanism for Earth crustal displacement was postulated to be the shear weight of the ice built up over time. This caused the crust to shift through unequal weight distribution. However, this weight is compensated for by isostatic depression of the crust. Finally, there is no paleomagnetic evidence for Earth crustal displacement having occurred. In Fingerprints of the Gods, Hancock hypothesizes that the demise of the mammoths and other megafauna was caused by a catastrophic cataclysm brought on through an Earth crustal displacement. The result was that terrible forces were unleashed on all living creatures during the last ice age and that the northern regions of Alaska and Siberia appear to have been the worst hit by the murderous upheavals between 13,000 and 11,000 years ago. In a great swathe of death around the edge of the Arctic Circle the remains of uncountable numbers of large animals have been found including many carcasses with the flesh still intact, and astonishing quantities of perfectly preserved mammoth tusks. Hancock 1995, 212, 213. Hancock makes a case for Siberia having experienced a warm climate before 11,000 BP and contrasts it with the conditions seen there today. As evidence, Hancock focuses on stomach contents. The mammoth died suddenly, in intense cold, and in great numbers. Death comes so quickly that the swallowed vegetation is yet undigested. Grasses, bluebells, buttercups, tender sedges, and wild beans have been found, yet identifiable and undeteriorated, in their mouths and stomachs. Hancock 1995, 215-16. The source for the quote by Hancock is a 1960 newspaper article by Ivan Sanderson. Hancock, 1995, 216, also claims, needless to say, such flora does not grow anywhere in Siberia today. Its presence there in the 11th millennium BC compels us to accept that the region had a pleasant and productive climate, one that was temperate or even warm. What is certain, however, is that at some point between 12 to 13,000 years ago a destroying frost descended with horrifying speed upon Siberia and has never relaxed its grip. In an eerie echo of the Avristic traditions, a land which had previously enjoyed 7 months of summer was converted almost overnight into a land of ice and snow with 10 months of harsh and frozen winter. The positions and actions of ice sheets are more complicated than the blanket portrayal and fingerprints of the gods. The Barents ice sheet covered most of northern Russia and goes unmentioned in Fingerprints of the Gods, as do the reasons behind why Siberia was not all covered in ice. Siberia lay west and southwest of where the Barents ice sheet had formed. There was insufficient snowfall to create enough ice to expand the Barents ice sheet into Siberia. Chinooks blowing down off the ice sheet, moderating the climate of the area in front of them, was the cause of the insufficient snowfall. North America was also subjected to its own Chinook winds. As has been documented with the Sierra Nevadas and other mountain ranges, the air descending 2 to 3 kilometers from the top of an ice sheet would be heated up to an average of 47 degrees centigrade. The areas of Siberia and North America in front of the ice sheets would have experienced a milder winter than present, although their summers were colder, which resulted in more conducive conditions for plant growth and for animals than those currently experienced. Moreover, a rain shadow was cast over Siberia by the ice sheet, and the Arctic Ocean, covered in ice, could provide little moisture for precipitation over Siberia. This scenario was tested by COHMAP, Cooperative Holocene Mapping Project, members, 1988, to found a dry Siberia, a glaciated Barents Sea, and a glaciated North America to be compatible. The frozen mammoths. Claims that the mammoths were quick frozen have been propounded for decades and were disputed by Zimmerman and Tedford as long ago as the mid-1970s. 1976, 183, histologic examination of rehydrated tissue samples from late Pleistocene Alaskan mammal mummies demonstrates that the preservative effect of freezing and drying extends to remains 15,000 to 25,000 years old. Some muscle and liver retained identifiable histologic structures. Most tissues were completely disintegrated and partly replaced by masses of bacteria, an indication of considerable post-mortem decay before the remains were entombed beneath the permafrost zone. These points were taken up and elaborated upon further by Curtin, 1986, 51-2. Various legends exist about frozen mammoths. It has been said, for instance, that the scientists who excavated the Bursovka mammoth, discovered in the year 1900, enjoyed a banquet on mammoth steak. What really appears to have happened, as I was told by Professor Anatol Hines, is that one of them made a heroic attempt to take a bite out of the 40,000-year-old meat but was unable to keep it down, in spite of a generous use of spices. The facts are not hard to find. In 1902, Otto Herz, a zoologist at the Imperial Academy of Sciences in St. Petersburg, published in German an account of the expedition to the Bursovka River which he had led the year before, with the purpose of salvaging the mammoth carcass that had been discovered in 1900. The point here is this: Herz definitely states that it was only the superficial part of the cadaver that had been preserved. The internal organs had rotted away before the animal had become frozen. Blue Babe, a mammoth that perished 36,000 BP, was discovered with its chest cavity torn open by predators, which allowed its body to be quick frozen. If it had been catastrophically frozen, it would have been too hard to tear open and be feasted upon. Second, its predators should have been quick frozen by the same catastrophe that overcame their feast. The size of the mammoths was an adaptive advantage to the cold environment in which they lived, and not to the warm environment postulated by Hancock. Low surface-to-body ratios helped to reduce passive heat lost through the skin. They had small ears and trunks by comparison with their African elephant cousins, who use their large ears and trunks to dissipate the heat. The mammoth's body was cold-adapted in other ways. They had a 10 cm thick undercoat, 50 cm long body hairs and a 10 cm layer of white insulative fat under the skin. The woolly rhinoceros, Coelodonta antiquitatis, also had a shaggy coat and a layer of extra fat underneath its skin. Mummified remains of these rhinos have also been found in the permafrost. permafrost plants. The plants and pollen found within the mammoths, together with the remains in the surrounding sediments, consist entirely of plant varieties adapted to cold climates. The plant remains found in the guts of the mammoth and other mummified animals from Siberia have been analyzed and summarized in detail by Ukraintseva, 1993. Further work on the climate of Siberia by Russian paleontologists, paleobotanists, and geologists has also been summarized in Ukraintseva, 1993. Siberia was not dominated by tundra when the mammoths lived. As Ukraintseva, 240, points out, integrated investigations threw light on environments of the concrete specimens of fossil animals discussed here and the mammoth fauna as a whole. Most of the mammals died in warm periods during the last 53,000 to 10,000 years when the vast territory of Siberia was covered by various forests, paludal communities and bogs, whereas communities of azonal character, meadows, steppe meadows, and others, which served as pastures to the mammals sharply reduced in area. Ukraintseva also says, cold, glacial, epochs were dominated by open, treeless landscapes such as Arctic meadows, various tundras, periglacial steppes. Remains of fossil trees, dated by C14 analysis, suggest that woody plants did not disappear completely during short cold phases of the last Pleistocene and Holocene. They remained as small forests and separate trees in the river valleys and serves as peculiar advanced posts for forest advance northwards at warm periods. The Arctic meadows, tundras, and steppes contained the herbaceous plants, leaves, and sprigs of shrubs and low shrubs needed for the mammoth to feed on and survive in glacial Siberia. The mammoths also had complex molars that were ideally suited for its macrograzing habitats. These data were available to Hancock when both editions of Fingerprints of the Gods were published. The problem is that the winters had to have been cold enough to freeze and mummify the remains, and the summers warm enough to melt the permafrost and produce mudflows to bury the carcasses. If the summers were too cold, then mudflows wouldn't have occurred and the carcasses be buried and preserved. If the winters were too warm, the carcasses would have been decayed or been devoured fully by predators before being preserved. The remains of Pleistocene mammals in Alaska and Siberia have been discovered in permafrost, which resulted in the body tissue being preserved through desiccation-induced mummification. The end of the last glacial maximum was a continuation of cyclical events occurring over hundreds of millions of years, which has its origins in slow cyclical changes in the tilt of Earth and Earth's eccentric orbit around the Sun. Although the latter is mentioned in Chapter 28 of Fingerprints of the Gods, entitled Machinery of Heaven, its implications are not discussed. These two Milankovitch factors combine to vary the amount of solar radiation different areas of Earth receive at different times in accordance with orbital forcing. Current cycles last 100,000 years and are affected also by ocean currents and the rise and fall of mountain ranges. In-depth analyses have been undertaken and presented by John and Catherine Umbre, 1979, as well as Wally Brooker and George Denton, 1990. The climate changes that affected the habitats of the mammoths, and other mammals, at the end of the last glacial maximum have been eloquently and concisely expressed by Vereshchagin and Baryshnikov, 1984, 506-7, winters with little snowfall and the development of a luxuriant grass cover on hard, dry ground with abundant summer insolation allowed horses, bison, and saiga to occupy huge expanses of northern Eurasia. The boundary between the Pleistocene and Holocene was characterized by sharp, short climatic oscillations, the B-inverted question mark Ling interstatile, 12,400 to 12,000 years BP, the middle Dryas statile, 12,000 to 8,000 years BP, and the Alarod interstatile, 11,800 to 11,000 years BP, the upper Dryas statile, 11,000 to 10,300 years BP, and so forth, which affected the Pleistocene species decisively. It was precisely in this time range that the massive extinction of the mammoths and their fellow travelers occurred in the Arctic zone. Testimony to this extinction are the hundreds of thousands of bones from disarticulated skeletons and the occasional frozen carcasses buried in sartan deposits, late Wisconsin, in northern Yakutia and on the Tajmir Peninsula. Judging from modern examples of mass death among wild and domestic ungulates in the Kazakhstan steppes, the best explanation for such death at the end of the Pleistocene is the frequent occurrence of snowstorms, blizzards, in winter and the transformation of the nutritious Pleistocene tundra steppe into a boggy, lake-dotted tundra. In subarctic latitudes at this time, taiga and mixed forests advanced rapidly onto open expanses, and a forest fauna developed. From the paleozoologist's point of view, the most convincing proof that the landscape changed radically on the boundary between the Pleistocene and Holocene is the change from a steppe, mammoth fauna into a forest fauna on the Russian plain, in the northern Urals, in Siberia, and even in the Far East, in Siberia, and even in the Far East, in Siberia. Hypotheses and propositions, both within and outside the scientific community. One of the most prominent unorthodox interpretations put forward was Charles Hapgood's Earth crustal displacement, which was never accepted as a truly valid competing scientific hypothesis, and Hapgood was not part of the geological community. Popularized in his 1958, revised 2001, on Hapgood's evidence for catastrophe at the end of the last glacial maximum, 12,000 BP, before present. Earth crustal displacement is based on the premise that Earth's lithosphere, the outer part of the rocky Earth, about the uppermost 80 kilometers or 50 miles, has shifted as a whole at different times in the past over Earth's interior. Hancock, 1995, 11, went so far as to claim no geologist has succeeded in proving it incorrect. Results from pollen analyses have revealed patterns of climate change that are at odds with the inherent predictions of the Earth crustal displacement model. Studies have shown that the polar regions heavy book Earth's shifting crust, a key to some basic problems of Earth science. The Earth crustal displacement idea has re-emerged in alternative circles in the last decade. Its most vocal supporters are the librarians Rand and Rose Flamath and the journalist Graham Hancock. Hancock based a large portion of his book Fingerprints of the Gods, 1995. Pole shift Earth crustal displacement, the climates and fauna of Siberia and Alaska, and the deaths of the mammoths, we finds it to be critically flawed. By the late 1960s the modern theories of continental drift and plate tectonics had become firmly established in geological thought. They had survived close scrutiny and challenges from competing